Hi, today I'm going to teach you how to derive two lenses in contact formula. Before going for that, I would like to ask you why are we just doing something like this? Give me, let me give you a good example. Sometimes you have to pull a certain box. You alone try to do that and you are just not enough for that. And you are asking the help from your friend who also joins with you and pull the box. Now you can pull. In the same way, sometimes you may have a very thin lens, right? Thin lens with you, and another thin lens with you, but you need a certain more powerful lens. So how can you do? If you can find a single lens has the same power, it doesn't matter. But sometimes you may have only two thin lenses, many thin lenses, but not the required lens. Then how can you do? By combining two lenses like this to get the same power of one lens. You understand? And sometimes you may have to reduce the power as well. So the best option is to you to merge this one with another. See, these two are perfectly fitting with each other. If you mix these type of things, actual converging ray might gain straighten and parallel. Right? You may need this type of results. The only way is to derive using this method. Have a good look at here. You keep one lens in contact with the other. You have to consider two main things here, reasons. Number one is you have to consider the thickness of these lenses to be zero, negligible. Zero means negligible. And the middle of these have the optical center, right? And just you need to replace both these lenses by a single lens. So you are going to find out the effective focal length of these two. Let's see how to do it. Right. Now see, two lenses are there. You are just going to shine a parallel light beam to this one. This light ray just travel across undeviated. Why? It is through the principal axis, through the point P. So now this one, here there is a certain thing. You have to only consider the first lens, F1 lens, and consider the other lens is not existing for this moment only. Definitely the ray will focus on here. Now this is where the image would form. If there is an object here, the image may form over here, right? This is the image for the first lens, but for the second lens, that will act as if a virtual object. Have a look at here. Now I'm only considering the first lens, the second lens, the first lens is just shadowed now. The ray may falling on it to somewhere here. This is where it was supposed to. See, now the ray may travel to there. That is the intended direction, but it is not. Okay, now use your IQ again. If you just shine a parallel ray to here, this is the F2 for the second lens. If you send a parallel ray just would fall on here. Now this one is already converged ray. Converge means it will get bent even more, even further than this. So it actually get bent to here. This is the new location. Previously this was the position. For the second lens, this is the object. So this is the final image, and the image distance is actually the effective focal length. Effective focal length. This is actually the F1 focal length. The image formed by the first lens is the location. For the object distance, the image formed by the second lens is the image distance. This is V, this is U, and this is F. Let's apply to the lens formula. 1 over V minus 1 over U equals to 1 over F. Right? 1 over V is 1 over Fe minus 1 over U is 1 over F1 for the first lens, the image. For the first lens, it is the image. But for the second lens, again I'm saying that is the object. Okay. Now for the final, it is the F2, Right, let me apply the sign convention. All have the sign convention of negative because all goes to there. In international level, it is the positive lens for the convex lenses, but in some streams, they have the negative sign convention. So I'll put the negative sign convention for all. Right, effective. Now you have to rearrange them. Okay, this goes to the other side. This goes to the other side. So once it goes to the other side, Fv equals to negative positive, other comes to here positive, 1 over F1 plus 1 over F2. That's such a simple equation to derive. And I have to tell you another thing. That thing is focal power is 1 over F. So 1 over F. So if you are using negative sign for the sign convention for certain syllabus stream, you may just add a negative sign for the in front of it to just cancel off that correction. Regularly in the international level, we just use the positive sign for the convex lenses. But if you use the negative sign, so it might be a problem. So put a negative sign in front according to for correction. That's it. That's all. So you can just see now F, E, 1 over F, 1 over F. So according to this, you can replace with the power equation. Total power, our effective power is equals to P1 plus P2. It comes up with the sign notation. Then you get the ideal answer for that. Thank you very much and subscribe to my channel.